All right, number 10, we have an application problem. This one says among all rectangles that have a perimeter of 82, we want to find the dimensions of one whose area is the largest. And then we're going to write our answer as fractions or reduce to lowest terms. Okay, so what we need to know is the formula for perimeter. So perimeter is 2 times the length plus 2 times the width is equal to, and then in this case it's going to be 82. Okay, then we want to know which one is going to give us the largest area. So we're going to say area equals L length times width, L times W. So we need both of these equations. We have two equations, two unknowns. We can solve it. So what we're going to do is we're going to solve for one of these variables. Let's just say we're going to solve for W. We're going to find the width. So we're going to use this equation to solve for width. I'm going to subtract the 2L and move it over. So I will have 2W equals 82 minus 2L. So that's just subtracting and moving L across. Now divide everything by 2, and we get that W equals, this will be 41 minus L. Okay, so now we have an equation with W in terms of L. We're now going to take this and plug it in here. So now we have area equals length times width, and width is 41 minus L. Okay, so we're going to distribute, and then we have 41L minus L squared. All right, so this looks like a quadratic. Okay, so I'm going to rewrite this with my L squared term up front. So I have my area equals a negative L squared plus 41L. Okay, so that's positive, so I just put plus. So this is a quadratic function, and since we want the maximum area, and we know that this is negative, meaning your parabola is going to be opening up and going downward, we're looking for that maximum point or that vertex. That's what we've been doing this whole time, finding the vertex. So we're going to find the vertex. I'm going to first find the x value. X equals negative b divided by 2 times a. Okay, so it's going to be a negative 41 over 2 times negative 1. So we have a negative 41 over 2 times negative 1. So it's going to be a negative 41 over negative 2. And divide and reduce. This will give us, do they want us to leave it in fractions? Okay, so I'm going to leave it as a fraction form. This is going to be positive 41 over 2. So this is what the x, I said x, I should use L because that's the variable that we're using. L is 41 divided by 2. So that is the length. And then to find the width, we're just going to plug it in to the original equation. So I'm going to say 2 times L, which is the 41 over 2, plus 2W equals 84. So times 2 is going to cancel out division by 2, so that leaves me with 41 plus 2W equals 84. Subtract 41. Why did I write 84? This is 82. I don't know where 84 came from. Yep. 82, sorry. Subtract 41, and it's going to give us 2W equals 41. And then divide by 2, and we get the same dimensions for W. So W is also equal to 41 divided by 2. And in most of these optimization problems, when you have a square, the side is going to maximize area is probably going to be the same most of the time, unless there's some kind of a different shape. But usually with squares and rectangles, they're the same, from my experience.